Hey everybody, it's the Wannabe Doctor. Man Fred here. He's gonna help us out. He's obviously dead, but he's cool. I dig him. Anyway, alright, this is Dr. Hannah's AP2 class, and stay tuned for more. Today we're gonna be talking about, in this video, the digestive system. And that would include this boy right here, the large intestine. Okay, so this is one thing we'll be talking about in this video as well, the large intestine.
In your body, this only takes place through the digestive system. You cannot eat through your nervous system or your eating system. Alright. So ingestion is going to be my first activity. What you're going to do for this ingested food, you're going to need to break it down. And we have two ways that we need to use, two mechanisms of digestion. We have the mechanical digestion, and this is simply a mechanical breakdown. You're going to be breaking down a large part into smaller parts. This doesn't essentially change the chemical structure. It's like putting a donut in a blender. The donut is going to be broken down into smaller pieces, but there is no change in the chemistry of the starch. You did not transform the complex sugar into simple sugar. So you need to break down on a mechanical level first, and at the same time on a chemical level. This will be my chemical digestion. Remember, where did we start both mechanical and chemical digestion? In the oral cavity. Choose the food, and the food now is going to be cold. When you mix it with the saliva, it's going to be the bolus. So you mix the food, you break down the food, and you mix the saliva with it. This is going to be the food bolus. Remember, this bolus is going to be broken down in the stomach on a mechanical level, again, by sugaring. And the food now is going to be cold the time when you mix it with the gastric secretion. So again, you start here. Food will be transformed in a bolus, and the bolus is when you mix the food with the saliva. When you mix the bolus now with the gastric secretions, it's going to be the chyme. The chyme will then pass into the small intestine, and we're going to be performing a mechanical digestion in the small intestine. Remember, when you divide the small intestine into smaller segments, so part will relax, parts will contract, and this will be called segmentation. Segmentation is a type of mechanical digestion. Did I change the chemistry of those particles? No, not. All right? Chemical digestion starts also with the oral cavity under the effect of the salivary amylase and lingual lipase, which are enzymes released in the saliva. Also, you're going to be completing the chemical digestion in your stomach under the effect of the hydrochloric acid and the pepsin. You're going to be completing the chemical digestion of some of the nutrients in your small intestine under the effect of the bile, the pancreatic secretions, and the secretions of the small intestine itself. So again, what we've done so far, we did ingest. We mechanically break down the food into smaller pieces, oral cavity, stomach, and small intestine. We chemically digest, we start the breakdown on a chemical level of the nutrients in the oral cavity, in the stomach, and in the small intestine. After you break down, what do you need to do? You need to absorb. I need to get the nutrients located in my small intestine now to move to my blood, for me to deliver those nutrients to my cells, for the cells to replicate, for the cells to repair themselves. So I need to absorb those nutrients to the blood. Is there any other place where the absorption going to be taking place other than your small intestine? Yes, some of the absorption going to be taking place in your large intestine. What's going to be absorbed in your large intestine? Water and vitamins. Why did you wait all this to get your vitamins in the large intestine? You didn't absorb those vitamins in the small intestine simply because they get formed in your large intestine by the bacteria flora. The bacteria colonizing your large intestine are the ones that will be producing those vitamins that you're going to be absorbing in the large intestine. You didn't have them in your small intestine to absorb. And if I have irritation, I've got an infection in my large intestine. This irritation or the infection in the large intestine will prevent me from absorbing the water from the feces. So what will I develop? I will develop diarrhea. I will be losing too much water with the stools. If I have slow contractions of the large intestine, the stools will remain for a longer time in the large intestine, allowing more absorption of water. So what I will develop over time, I will develop fecal stones. Constipation will result in fecal stones. Why did you develop stones? You absorb lots of water out of the feces. So after you complete the breakdown, you absorb what you want. What you're going to do with the remaining part of the foods, if you were not able to break down or you are not absorbing, what you're going to do is this going to be removed from your body by defecation. So another activity here of the digestive system is going to be defecation. Also is going to be taking place in different parts of the gastrointestinal tract. So I need to have the ability to move the food throughout my gastrointestinal tract, all the way from the oral cavity to the anus. What allows the movement of the food all the way from the oral cavity to the anus is going to be the propulsion. What kinds of propulsion do we have? Moving from the oral cavity down to the esophagus, we did have deglutition or swallow. Starting from the esophagus to the stomach, small intestine and large intestine, you are going to be performing peristalsis. And remember, peristalsis is due to the contraction of the longitudinal muscle layer. You remember? I have remember, if I did have, this is the food bolus traveling down into my esophagus, so the esophagus will contract and relax, contract, relax, pushing the food down. If I am moving along my small or large intestine, contraction, relax, you contract, relax, contract, relax, contract, relax. So the food is going to be moving due to the longitudinal muscle layer contraction. This allows the peristalsis to take place. All right, so again, how will I be able to move the food along my gastrointestinal tract from the oral cavity to the anus? First, you start by swallowing, and then we keep going by peristalsis. Remember, Swallowing, is it a voluntary or an involuntary process? It's both. You start the pharyngeal, buccopharyngeal phase of swallowing. This would be a voluntary process, and you keep going down along your esophagus to reach the stomach. This would be an involuntary process. We have two phases of deglutition or swallowing. You start by the buccal phase. It's a voluntary phase. And remember, what you're gonna do in order to start swallowing, you're gonna be contracting your tongue against the hard palate. And when you contract your tongue against the hard palate, this creates a high pressure within your oral cavity, moving the food backward to your oral pharynx. Remember, we did discuss the 4 layers of the gastrointestinal tract from inside out. We did see mucosa, then we're gonna have the submucosa, then we have the muscle layer, musculosa or muscularis externa, and the outside we did see the serosa. Remember the general rule of the muscle layer. How many muscle layers do I have in the gastrointestinal tract? Generally speaking, I have 2 muscle layers. I have an outer longitudinal muscle layer and an inner circular muscle layer. Exceptions that we've seen last time for this general rule was my pharynx. Remember, pharynx did have an outer constrictor, inner longitudinal muscle layer. And remember why it was not a problem, why having constrictors to the outside will not interfere with the blood supply with the longitudinal muscle layer. Remember, the pharyngeal muscles are skeletal muscles. They are fatigable, and you will not be swallowing for a long period of time throughout the day. You're going to be contracting those muscles for a very brief period of time, and this will not cause an interruption of the blood supply to the longitudinal muscle layer. So I won't have a problem in my pharynx. Remember, after you get the food down to the esophagus, it did move to the stomach. And in order for me to move the food from the stomach to the small intestine, I did need special types of movement in the stomach. I did have the propulsion. I am moving the food down towards the pylorus, and only a small part of the food is going to be passing from the stomach to my duodenum, and the major part of the food is going to be moving backwards into the body of the stomach. This backward movement of the food into the stomach, this is what we call the retropropulsion. Can you remind me, why did I have this in the stomach? Why am I allowing only a small portion of the food to travel to my small intestine, not all the food to pass at once? Why do you think?
Would it be too much pressure on the small intestine?
Yeah, it's too much pressure.
Like too much going into it all at once, and it may rupture it?
So what's wrong with it?
It's
So too much to pass. It's actually so long, it can accommodate much more than the stomach actually.
Oh. The food needs time to break down in the stomach before it can pass through the small
But you can still break down in the small intestine. If I did remove the stomach, will I be able to digest?
Yes.
If I have bypass surgery, I'm bypassing the stomach, I'm still gonna be able to digest. I will rely mainly on the small intestine to break down the food. You remember why it is so important to only allow a small part of the food to travel from the stomach to the small intestine, and I will be pushing back most of the food into the stomach.
So you keep some stored.
So you don't feel hungry after.
Oh.
Yeah, this is a good way to think of it. Yeah. Because it's very close, very close. So what do you think? What might happen if you pass all this food all at once to your small intestine? Your small intestine has a huge surface area for absorption. So all the nutrients can be absorbed all at once.
That's what I was
And this
thinking.
will cause
I
a
wish I'd said
sudden
that.
rise of the blood sugar level.
That's what I was thinking.
So
I wish I said it.
normally, I am regulating the blood sugar level. It shouldn't go that high. So the pancreas will be releasing large amounts of insulin, and this large amounts of insulin that you're going to be releasing from the pancreas actually will drop the blood sugar level even below normal. So that's why if a person has a bypass surgery, we actually tell him not eat sugary food. Because if you eat sugary food, too much sugars, you're gonna have dumping syndrome. You're gonna lose consciousness. You're gonna have hypoglycemia. Because you're gonna be releasing, you're gonna absorb all this if you eat like 2 teaspoons of Nutella or chocolate. So this absorption, this sudden rise of the blood sugar level will be stimulating the pancreas to release large amounts of insulin, and this will cause a major drop in your blood sugar. This will cause hypoglycemic coma.
What if you're diabetic?
If a person is diabetic, according to whether he has type 1 or type 2. If he has type 1, he's not producing insulin. If he has type 2, the surgery will help him when he loses weight. He might actually just losing weight will let him get rid of the diabetes. It's according to the reason and the extent of the disease. Alright? So you see on here, you're going to be pushing the food down, passing through the sphincter. What do we call the sphincter of the pylorus of the stomach? Pyloric sphincter. So only a small part of the food is going to be traveling down from the stomach to the duodenum, and most of the food will go backwards. This backward movement of the food is what we call retropropulsion. The most vigorous contractions that will be taking place in the stomach will be taking place in the pylorus, in the pyloric canal. And this vigorous contraction is what will result in the grinding movement on here. This will be the major mechanical digestion that we're going to be performing in the stomach. So the most vigorous contractions of the stomach are going to be taking place in the pyloric canal, not in the body, not in the fundus, not in the cardiac. This is where I will be performing the churning of the food. Mechanical digestion mainly takes place in the pylorus of the stomach. Alright? Remember, do I need to get signals from the nervous system to initiate my contraction of the stomach? No, I generate my own electrical impulses, like what we see in the heart. I have my own pacemaker. What did we call the pacemaker of the stomach? That will be generating 3 contraction waves every minute. This is what we call the cells of Kajal. Cells of Kajal. Here, those are the cells responsible for the generation of the electrical impulse causing the stomach to contract. All right? Questions? A quick reminder also of the cells of the mucosa lining of the stomach. Can you remind me what are the three types of mucosal gastric cells? We did see parietal cells, chief cells, and the enteroendocrine cells. What was the function of the parietal cells? Parietal cells are going to be releasing two things. I am producing hydrochloric acid and I'm producing intrinsic factor. Remember, what is the importance of the hydrochloric acid?
It activates.
I have activation of the pepsinogen into pepsin, which is going to be performing the first step of the protein digestion. It's also going to be denaturating the proteins, and it will be killing the ingested bacteria. It's like one of the first lines of defense against the pathogens. Another thing that we were releasing from the parietal cells, if you remember, this was my intrinsic factor. And remember, intrinsic factor is going to be needed for you to have a normal absorption of what vitamin?
B12.
Vitamin B12. And if I don't have intrinsic factor, will I be able to absorb vitamin B12 in the small intestine? No. Having vitamin B12 deficiency, this will cause a type of anemia that we're going to be discussing in the blood in the next few. All right, so you see on here, two major things that will be produced by the parietal cells. The chief cells will be releasing the inactive form of the pepsin, which is my pepsinogen. And the pepsinogen is going to be activated again by the hydrochloric acid and the active form, which is the pepsin. And a third type of cells that we've seen, those will my enteroendocrine cells. And remember, entero means related to gastrointestinal tract, endocrine, I am releasing hormones into blood. Like what hormones are you releasing? Like the gastrin. And remember, the gastrin is a hormone that stimulates the contraction and the gastric secretion of the stomach. I am enhancing the stomach to release their secretions to contract. Alright, so what are the digestive processes of the stomach? Do you perform any chemical digestion? Yes? Yes? Do we have any ingestion through the stomach? Do we eat through the stomach? No. No ingestion? Do we have any propulsion?
Yes.
Yeah, what kind of propulsion do you have? Peristalsis and cerebral propulsion. Yes. Do we have any mechanical digestion? Surely.
Yes.
Where this will take place? Where do I have the most vigorous contractions of the stomach? In the pylorus. Pylorus canal of the pylorus. So the good answer here is going to be A, C, and D. Alright. Let's go out to the atlas on here.
Are we doing chapter 24?
Yes. After we're done with this.
When you said about the mechanical digestion, I thought it was a maintenance function of the oral cavity.
Overshare. So if you are swallowing without having any mastication of the food, so you have rely mainly on the stomach and small intestine. Alright, so part of the mechanical digestion takes place in the oral cavity, but also you're going to be performing mechanical digestion in the stomach and the small intestine. Alright? So you see on here, those are the different parts that we've seen in the stomach. First, we have
Down, higher, to the left. To the left, down.
this first part that I can see on here. This is the cardiac region.
Mhm.
Dome-shaped part of the stomach. This is the fundus of the stomach. Middle portion, all of them is going to be the body of the stomach. Body of the stomach. And then this tail part, starting from almost here down, this is the pylorus. You see on here, I have this C-shaped part of the small intestine that will be surrounding the head of the pancreas. See on here, we're going to be conducting the food down from the esophagus to the body and the fundus of the stomach to the pyloric antrum, pyloric canal, and if you hide this part, you will see this sphincter that you're going to be passing through to be conducted to the small intestine. This is the pyloric sphincter that will act as a valve. It will only allow the food to move from your stomach to your small intestine and not backward. The C-shaped part that I see on here of the small intestine, this proximal part is the duodenum. Then I will have the jejunum, and the distal part is going to be my ileum. So, duodenum, jejunum, and this distal part is going to be my ileum. You see on here, the ileum is going to be conducting the remaining part of the food that you did not absorb or you failed to digest to this pouch-like structure of the large intestine. This is the cecum. You see on here, if I get closer, I have a valve between the ileum and the cecum. So we're going to call this is my ileocecant valve. So for you to move the remaining part of the food from your small intestine to the large intestine and not the stools from the large intestine back into your small intestine, I am allowing a unidirectional movement to take place up here from the ileum to the large intestine, from the ileum to the cecum. So again, three different parts that we see on here. This C-shaped part, this is my duodenum, jejunum, and this would be my ileum. Starting with the duodenum will be receiving secretions from the pancreas and the liver. You see on here, if I get closer, can you imagine this is the liver on here? The liver, one of its functions, one of the functions of the liver cells, of the hepatocytes, is to release the bile. The bile is going to be needed for you to start the digestion of the fats. So if I have a fat particle, is the fat water soluble or not? What do you think? If you put oil in a cup of water, will you be able to mix the oil with water? No. Then it will separate, right? So if I have a large droplet of fat like this, And those are the enzymes that will be breaking down this fat. So they are only going to be exposed to the outside surface of this fat droplet. So I need to make it more soluble. This process of the emulsification of the fat is simply transforming the fat into a smaller droplets, makes it more soluble. It's like acting as a detergent. So how do you wash your dishes?
Dish detergent.
Use detergent by itself, or you need to use detergent and water. So what is the action of the detergent? What the detergent is doing?
Break
Is
it down.
breaking down the fat?
It dilutes the fat.
It makes it more soluble in water. It reduces the surface tension between the water molecules, allows the fat particles to travel between the water molecules. I am making it more soluble, so I will have a better exposure to the digestive enzymes. So you see, the area exposed to the enzymes will be increased when you emulsify this fat. So the first step in the digestion of the fat is the emulsification. So again, what will be emulsifying the fat to make it more soluble in water is going to be the bile released from your liver cells. So you have a duct conducting the bile from the right lobe of the liver, a duct that conducts the bile from the left lobe of the liver. Those are my right and left hepatic ducts. Right hepatic duct and left hepatic duct. Both of them will form the common hepatic duct. So both of them will fuse together and will form a common hepatic duct that will be connected to a muscular sac located on the ventral surface of the liver. This is my gallbladder. This bile that you're going to be releasing from the liver will be stored in the gallbladder until you get food in your duodenum. So the function here of the gallbladder, as we're going to see, is to concentrate the bile, to absorb the water out of the bile, make it concentrated. Once you get food in the duodenum, you're going to be contracting the gallbladder and release the bile into the duct coming out of the gallbladder. This is my cystic duct. Cystic duct with the common hepatic duct that will form my common bile duct. You see on here, the common bile duct will be fusing with the duct coming from the pancreas. You see on here, you have a pancreatic duct. It fuses with the common bile duct and will form what we're going to call the hepatopancreatic ampulla. So if I hide this part, so this junction between the common bile duct and the main pancreatic duct will form the hepatopancreatic ampulla that will be conducting both the bile from the liver and the pancreatic secretions to this proximal part of the small intestine. Again, this C-shaped proximal part of the small intestine is what we call the duodenum. All right. So again, what we've seen so far, we've seen the ducts that will be conducting the bile down from the liver. We have the left hepatic duct, right hepatic duct. Both of them will fuse together to form my common hepatic duct. Common hepatic duct will be conducting the bile to be concentrated in the gallbladder. The gallbladder will be releasing the concentrated bile, once you get food in your small in the duodenum, and you see on here, it will contract to conduct the bile to the cystic duct, then to the common bile duct. For the common bile duct to fuse with the pancreatic duct. We call the pancreatic duct on here. This is my main pancreatic duct. And I will form the ampulla here. This is called my hepato, related to the liver, pancreatic ampulla. So the hepatopancreatic ampulla is the junction between the common bile duct and the main pancreatic duct. It's going to be conducting both the bile and the pancreatic secretions to this part of the small intestine. All right? Questions? Questions? Yes.
But when people get their gallbladder removed, how do they survive after that? What do they do?
They will not be emulsifying that effectively. So yeah, so I will still gonna be conducting bile to the small intestine, but it's gonna be less concentrated, and this bile is gonna be conducted all the time. So I'm not storing the bile, concentrated, and then release it once I get food. So you're still gonna be releasing the bile from the liver, but it's not gonna be that effective. All right, so that's why if a person removes his gallbladder, we usually ask the patient to not eat fatty foods. Because if you eat lots of fats, what's going to happen, you will not be able to break down those large fat droplets because you have very minimal exposure to the digestive enzymes. So if you didn't break down those fats, who will love to break them down for you? The bacteria living in your large intestine. So you're going to be developing gases, you're going to have steatorrhea. So you're going to be adding fats to the stools. So the stools will be floating in the toilet. Alright, if a person did remove the gallbladder and he eats lots of fat. Alright, so it doesn't have like major complications other than having gases and stuff. Alright? But we usually remove it if I have an infection of a stone or inflammation. So if I concentrate the bile to the extent where I'm forming stones, this is a risk factor for having an infection that might end up by a rupture or something. So we remove the gallbladder. Question?
That's what my
Questions? So, back here to the small intestine, the first part of the small intestine here, this would be the duodenum. It's going to be receiving the secretions from both the liver and the pancreas through the hepatopancreatic ampulla, and this hepatopancreatic ampulla is going to be guarded by a muscle, a sphincter, that will be regulating the passage of the pancreatic secretions and the bile into the small intestine. You see on here, I would have an elevated ridge around the entrance of the hepatopancreatic ampulla. This will be my duodenal papilla. So this elevated ridge at the entrance of the hepatopancreatic ampulla, this ridge on the inside is my major duodenal papilla. Alright, so here we're looking at right and left hepatic ducts, common hepatic duct. This will be my gallbladder conducting the bile to the cystic duct that fuses with the common hepatic duct to form the common bile duct. Common bile duct will be fusing with the main pancreatic duct coming from the pancreas, and this together will form my hepatopancreatic ampulla, which is guarded by a sphincter. So what we call the sphincter around the hepatopancreatic ampulla, this would be my hepatopancreatic pancreatic sphincter. To the inside, you see on here is this elevated bridge around the entrance of the ampulla in the duodenum. This will be my major duodenal papilla. All right. Moving on to the next part, jejunum is the middle segment and it's 8 feet in length. The distal part of the small intestines is going to be the ileum and it's going to be 12 feet in length. It ends at the cecum. And remember, you have a valve between the ileum and the cecum. This is what we're going to call the ileocecal valve. So ileocecal valve here is going to be guarding the movement of the food from your ileum to the cecum and prevention, and is going to be preventing the feces from moving back to your small intestine. I'm allowing the food only to move from the ileum to the large intestine, not back. Again, here, what is the sphincter on here between the ileum and the cecum? It's my ileocecal valve. Ileocecal valve. What are the different actions here of the small intestine? The small intestine is going to be performing chemical digestion under the effect of first the bile coming from the liver and the gallbladder. Remember, liver cells are going to be producing the bile. This bile is going to get concentrated in the gallbladder. You're going to be releasing this concentrated bile by contracting the gallbladder once you get food in the duodenum. See on here, also chemical digestion will be taking place in the small intestine under the effect of the pancreatic secretions, like what enzyme is going to be produced by the pancreas, like my trypsinogen, procarboxypeptidase, chymotrypsinogen. All those are enzymes breaking down proteins. Pancreatic lipase, this is going to be responsible to break down lipids. So lipase is to break, and light here is going to be lipids. So lipases, you're going to have amylase, and amylase is going to be responsible to break down the sugar, starch. Also, you're going to be breaking down the DNA and RNA. This is going to be taking place by the nucleus. So you're going to be breaking down everything by the pancreatic secretions. You're going to be breaking down proteins, you're going to be breaking down carbs, you're going to be breaking down fats, and nucleic acids. Also, the small intestine is going to be releasing its own digestive enzymes, and we call those enzymes released from the small intestinal cells. Those are the brush border enzymes. Brush border enzymes, this includes like enteropeptidase. We're going to have other secretions like the secretine and the cholecystokinin. Another major function of the small intestine is to allow absorption to take place. I have a huge surface area for absorption, almost equal to the size of a tennis court. What provides you with this huge surface area for absorption in your small intestine? First, the length of the small intestine. I have a very long tube. Another thing is those villi, those folds formed by the mucosal lining of your small intestine. You're going to have mucus folds forming the villi, and the surface of each one of the cells will have microvilli. Don't get confused between the villi and the microvilli. Microvilli are projections from the cytoplasmic membrane of the intestinal cells. Compared to the villi, those are the elevated parts of the mucosal lining. So this will be full of thousands of cells. One villus will be full of thousands of cells. Microvilli are those elevated parts on the surface of each cell. So you're going to have villi of the mucosal lining, and you're going to have microvilli in each one of those cells forming my villus. So it's like doubling, tripling the surface area for absorption. Questions? Am I going too fast? No? Did you sleep already? Or was it slow? All right. Other function of the small intestine is to allow propulsion. Remember, two types of propulsion. Two types of propulsion that will be taking place. First one is concerned with mechanical digestion. This is called my segmentation, and the other one is going to be to allow the movement. This would be peristalsis. So you allow the movement by peristalsis. You break down the fluid on a mechanical level. This would be segmentation. See on here the same layers that you've seen in the gastrointestinal tract will be present on here in the small intestine. Remember, the innermost layer is my mucosa, and you see the mucosa is going to be forming those villi, those elevated finger-like projections of the mucosal lining. Those are my villi. Also, I will form pits. I have depressions or crypts. So you're going to have elevations and depressions in the mucosal lining of your small intestine. What do we call the elevated part? This is my villus. What do we call the depressed part? The troubles inside. This is going to be my crypt. So you're going to have villi and crypts in your mucosa of the small intestine, and this all will share in increasing the surface area available for the absorption to take place. All right. Inside the core of the villus, we're going to have the blood vessels, veins, arteries, and the lymphatic vessels traveling to the inside. Moving on to the accessory digestive glands, the largest gland of the body is going to be the liver. I have four main lobes of the liver. Those are the right, left, caudate, and quadrate lobes. So you see up here, let me show you this part on the atlas. You see, all this part is my right lobe. This part is my left lobe. If I'm looking from underneath.
You can make everything else look interesting.
You have to select this part.
Especially this part. Two of them.
You see on here, those are on the right lobe, the left lobe. If I'm looking from the ventral surface, inferior surface, this is going to be my still part of the right lobe, but it's going to be considered a separate lobe. This is called the quadrate.
Right.
This here is going to be my caudate lobe, or lobus caudatus. All right, so you see on here, this is my right lobe, left lobe. This would be my quadrate, and this is going to be my caudate lobe. All right, so those are again my 4 main lobes. We have different divisions of the liver. This is a very basic, very old classification of the lobes of the liver. We have much more advanced classifications according to the blood supply. Right? Clinical classification of the liver is totally going to be different. This is going to be determined according to the blood supply of which area. We don't use those anatomical lobes in order to treat a cancer, for example, or to perform an implantation of a liver transplant. All right, those are anatomical lobes. We're going to be subdividing them into smaller lobes, but we will not be going to this extent. All right, for us, we have 4 main lobes: right, left, caudate, and quadrate. This is not a clinical classification. This is anatomical classification. All right? What's the name of the cells? That would be 4 means. Liver is going to be formed by hepatocytes. And the functions of the hepatocytes, this includes the processing of the blood-borne nutrients. Remember, all the nutrients that we're going to be absorbing from the small intestine, from the large intestine, all the blood that will be drained from your stomach will be traveling to the liver to be detoxified and modified. Also, the liver is going to be storing the fat-soluble vitamins. Like what fat-soluble vitamins do you know? Those are my vitamins K, E, D, and K. Alright, so for fat-soluble vitamins, K, E, D, and A. Alright? Also, one of the major functions of the hepatocytes is to perform a detoxification of the toxins and the medication, and that's why in some cases I will need to take a medication, intravenous or sublingual, for example, to conduct the medication directly in the bloodstream and to not pass through the liver. Because if I take the medication through my gastrointestinal tract, once it gets absorbed, the first station is going to be the liver, and the liver cell is going to be breaking down this medication, and it will never reach my target organs that I want the medication to act on. Question?
Do we need to know that?
Very basic knowledge.
I know, I'm just saying.
General knowledge, but it will not be test knowledge.
Oh, all right.
We can have test you on it, if you want.
I'm just saying, I want to make sure.
Alright?
It's not something that we're focusing on.
Alright? Another major function of the hepatocytes will be to produce the bile, and we are producing almost 1 liter of bile every day, but you're not releasing all this bile directly in the small intestine. It gets concentrated in the gallbladder before it gets released. Moving on to the gallbladder, and the gallbladder is a vascular sac located on the ventral surface of the liver. Functions is going to be to store and concentrate the bile by absorbing the water and ions out of it. It's going to be releasing the bile to the cystic duct, and then to the common bile duct. This is where it's going to meet with the pancreatic duct to form the hepatopancreatic ampulla, like what we've seen a minute ago. Moving on to the pancreas, and the pancreas is the exocrine and endocrine glands. I have both. Remember, what is the endocrine function of the pancreas is to release what hormones? What hormones do we release from the pancreas? We're releasing insulin and glucagon, if you remember. So this is my endocrine part, and we're not concerned with this part in this chapter. We are concerned with the secretions that will be released through the duct. Exocrine. I'm not concerned with the secretions directly released in the bloodstream. What do you release through the pancreatic duct? You're going to be releasing the enzymes, water, and bicarbonate. And this will tell you why we mentioned a reason for developing metabolic acidosis was having diarrhea. Why having diarrhea will cause acidosis?
You're getting rid of all the.
Because I'm losing lots of bicarbonate. And the bicarbonate is present in the pancreatic secretions. So you're going to be losing those bicarbonates to the outside rather than absorbing them back to your system. So you're losing bicarb, you're losing alkalis. So who takes the upper hand is going to be the acids. So a reason for metabolic acidosis, like what we mentioned back in the kidney, was having extensive diarrhea. And what is the source of the bicarb that will be lost is going to be your pancreas. All right? Moving on to the steps of the digestion and absorption of the different nutrients. First type of nutrients that we're going to be ingesting is going to be the proteins. Proteins, those are going to be formed by chains of amino acids. First site of protein digestion is going to be taking place in your stomach under the effect of the pepsin. They need to have my labels. All right, so we'll start here with large proteins, and those proteins are going to be broken down into polypeptide chains, smaller proteins, under the effect of the pepsin of your stomach. Then those polypeptide chains are going to be broken down into smaller polypeptide chains under the effect of the pancreatic digestive enzymes. And remember, 3 pancreatic enzymes that will be breaking down the protein. Those are going to be the procarboxypeptidase, the trypsin, and the thymotrypsin. So trypsin is going to be produced in an inactive form. This is the trypsinogen that would then become activated under the effect of the brush border enzymes of your small intestine. So you're going to be releasing those enzymes in an inactive form. Those enzymes will only going to get activated in your small intestine. Why do you think you need to activate them only in your small intestine? For you to not break down your pancreas. If you did get an activation of those enzymes outside in the pancreas, outside of in the peritoneal cavity, what I will end up with, I will end up digesting my organ. What keeps me protected in the small intestine is that the small intestinal cells are going to be forming thick mucus layers, so they are protected from those digestive enzymes. And that's why it's so difficult to deal with a pancreatic cancer. The surgery itself is so complicated because if you did leak enzymes outside in the peritoneal cavity, this will cause inflammation, this will be destroying everything around. So those enzymes are going to be breaking down those polypeptide chains into simple ones, but this will not be a form of proteins that I'm able to absorb. I need to keep breaking down those small polypeptide chains into either amino acids or maximum dipeptides, 2 amino acids attached together. Those are the forms of proteins that I can absorb. So what's going to be breaking down, complete the digestion here of those proteins are going to be those brush border enzymes, the enzymes produced from the intestinal cells. So 3 steps in order for me to break down the proteins. Start the first step in the stomach. Then you're going to be completing the performing a partial breakdown of those polypeptide chains into small ones under the effect of the procarboxypeptidase, the trypsin, and the chymotrypsin. Those are the enzymes produced from the pancreas. Will this allow you to complete the digestion? No, not yet. You need to complete the digestion under the effect of the brush border enzymes of your intestinal cells. This will result in the production of either single amino acids or 2 amino acids attached together. Those are my dipeptides. Congratulations, you have broken down the proteins. This is your intestinal lumen. This is your intestinal cell. And this would be your blood vessel. Absorption, simply speaking, is the transmission of those nutrients from the intestinal lumen to your blood vessel. So in the intestinal lumen, here I have amino acids, single amino acids, or dipeptides that I'm able to absorb. Single amino acids are going to be absorbed by co-transport with sodium. So you get the energy needed for the absorption of the amino acid by moving sodium actively. So here, this is an active membrane transport. You are allowing sodium, and at the same time, you're going to be allowing an amino acid. Compared to the dipeptides, those dipeptides are going to be absorbed by co-transport with hydrogen. As you conduct those dipeptides to the inside of the intestinal cell, you're going to be using this hydrogen to break down the peptide bonds between those amino acids. So now I will end up having only single amino acids in my intestinal cell. You have only single amino acids. Even the dipeptides, you're going to be broken down into single amino acids by the hydrogen you did transport them with. So This will create a high concentration of amino acids inside your intestinal cells compared to your blood. But the amino acids are going to be charged. They are not lipid soluble. They cannot pass through my phospholipid bilayer. I need to have carriers to transport those amino acids down the concentration gradient. This is a passive transport, but it requires the presence of a carrier. This is what we call a carrier-mediated, facilitated diffusion. This is my facilitated diffusion. I am passing from high concentration to low concentration. But I cannot pass through the phospholipid bilayer. I need the presence of a carrier to transport those amino acids. So is this an active or a passive process? It's a passive process, but it requires the presence of a carrier. So again, how did I absorb the proteins? What are the absorbable forms of the proteins first? Either single amino acids or dipeptides. Single amino acids will be transported to the intestinal cells by co-transport with sodium. Compared to the dipeptides, they will be transported to the intestinal cells by co-transport with hydrogen. Will you keep those dipeptides as dipeptides to be transported to your blood?
No.
No, you're going to need to split them into single amino acids. Break them down into single amino acids. So how would you break them down? By the hydrogen that you did just transport them with. Alright? Now I have high concentration of amino acids in my intestinal cells compared to my blood. So why I don't pass by simple diffusion through my plasma membrane? Because simply I am not lipid soluble. I am not lipid soluble, so you cannot be transported through the phospholipid bilayer. So you're going to need a carrier. So what is the type of diffusion here that requires a carrier or a channel? This is a facilitated diffusion. It's not a simple diffusion. It's a facilitated. It requires either a channel or a carrier. All right? Questions on how to break down, how to absorb proteins? As you see on here, you start with the proteins, going to be broken down into large polypeptides under the effect of the pepsin and the hydrochloric acid produced from your stomach. Then you're going to be transforming those large polypeptide chains into smaller polypeptides under the effect of the trypsin, the chymotrypsin, and the carboxypeptidase. Those are the active forms of the trypsinogen, chymotrypsinogen, and the procarboxypeptidase. This will allow you to transform those small polypeptides into, as well as the brush border enzymes on here, into single amino acids or dipeptides. Single amino acids are going to be broken down, going to be transported by co-transport with sodium from your intestinal lumen to your intestinal cell. Compared to the dipeptides, they will be transported by co-transport with hydrogen. This hydrogen is going to be used to hydrolyze the peptide and break down the dipeptides into single amino acids when we get into the intestinal cell. Now inside my intestinal cells I have high concentration of amino acids compared to my blood, so I can perform a diffusion, but those amino acids are not lipid soluble. So how will you be transporting them? Facilitated diffusion instead. You're going to require the presence of a carrier. So those amino acids will pass here by facilitated diffusion. Moving on to our next type of nutrients, this is going to be the carbohydrates. Carbohydrates, you start by breaking down starch, complex sugar. First, under the steady amylase, it will have a very minimal effect. Then you're going to be breaking it down by the pancreatic amylase. This will transform those complex sugars into oligo or disaccharides. Oligo means few sugar units. Disaccharides, I have formula of how many sugar units? 2 sugar units. Like what disaccharides we know? Like the lactose, the sugar of the milk, maltose, the sugar of the bread, and the sucrose, the sugar of the fruits. So those disaccharides are not going to be able to be transported, to get transported to the inside of your intestinal cells. You need to break them down into monosaccharides. When you break down the lactose, you're going to be producing 2 monosaccharides. One is the galactose and the other one is the glucose. When you break down the maltose, you're going to be producing 2 glucose. When you break down the sucrose, you're going to be producing 1 glucose and 1 fructose. The monosaccharides are going to be the absorbable form of your carbohydrates. Your intestinal cells will only be able to absorb your monosaccharides. You're asking about the break?
Oh, no, I had a question about that.
All right, so again, you start with complex sugars. You break them down by the steady amylase, pancreatic amylase, into oligosaccharides or disaccharides. Those disaccharides can be broken down by the brush border enzymes of your intestinal cells. Like what brush border enzymes that will be used down here? You're going to be breaking down the lactose by an enzyme called lactase. You're going to be breaking down the maltose by an enzyme called maltase. You're going to be breaking down the sucrose by sucrase. Those are examples of the brush border enzymes that will be released from the intestinal cells and will allow you to transform the disaccharides into monosaccharides. So now you've got monosaccharides in your intestinal lumen. How would you be able to absorb those monosaccharides? So this is my intestinal lumen on here. This is my intestinal cells. This is the brush border. Those are my microvilli. And this would be my blood vessel. You've got 3 types here of monosaccharides. You've got galactose, you've got glucose, and you've got fructose. The galactose and the glucose are going to be transported like the single amino acids by co-transport with sodium. Compared to the fructose, it's going to be transported from its high concentration gradient to a low concentration gradient within the cells by facilitated diffusion. I will need a carrier to be transported from my high concentration to my low concentration gradient. So again, with the galactose and glucose, you're going to be transporting them by co-transport with sodium. For the fructose, you're going to be transporting the fructose from the intestinal lumen to the intestinal cell by facilitated diffusion. You've got now your galactose, your glucose, your fructose inside your cell. Those monosaccharides will create a high concentration gradient within your cell compared to the low concentration gradient to the outside in your blood vessel. So all of them gonna be transported from the high concentration gradient to the low concentration gradient in your blood, passing through a carrier. Why I'm not able to transport those monosaccharides directly through my phospholipid bilayer? Because again, they are not lipid soluble. So they will need a carrier to transport them down the concentration gradient. Did I consume any ATP on here? Is this a passive or an active process? It's passive. I just need the presence of a carrier. But it's going to be passive. You don't consume any ATP to conduct the glucose, galactose, and fructose from the intestinal cell to your blood. They will travel down the concentration gradient. What do we call this type of diffusion that requires a channel or a carrier?
Facilitated.
So again, how do I absorb single amino acids? Single amino acids is going to be absorbed by co-transport with sodium to travel to the intestinal cells, and will be traveling from the intestinal cell to my blood by facilitated diffusion. Dipeptide is going to be transported from the intestinal lumen to the intestinal cell by co-transport with hydrogen. You're going to split those dipeptides into single amino acids in the intestinal cell. Single amino acids would be transported then to your blood by facilitated diffusion. For the glucose and galactose, they are transported from the intestinal lumen to the intestinal cell by co-transport with sodium. Fructose is going to be transported down its concentration gradient through a channel. This is what we call a facilitated diffusion. And all of the three of the monosaccharides on here are going to be transported from their high concentration gradient in the intestinal cell to their low concentration gradient in the blood by, again, facilitated diffusion. Questions?
So the protein digestion, one part you said was an active part.
The active part is the co-transport. And remember when we mentioned the co-transport back in the kidney, you paid for one, but you paid, right? So I paid here to transport the amino acid from the intestinal lumen to the intestinal cell. But do I pay another time to transport those amino acids from the intestinal cell to the blood? No. They will travel by facilitated diffusion. It's a free passive transport. Same concept for my galactose and glucose. They are traveling by co-transport. Co-transport is an active process. You pay for one, you get two, remember? The transport here is going to be taking place from the intestinal lumen to the intestinal cell.
Okay,
but they will be transported then by facilitated diffusion for free.
Okay.
All right. Moving on to our third type of nutrients, this is going to be the fats. Fats going to first need to become emulsified for them to get exposed to the digestive enzymes, and again, what emulsifies the fat is the bile released from your liver. This emulsified fat is going to be broken down by the pancreatic lipase and some broad proteins. This will be breaking down the fat into two major forms, glycerol and fatty acids. This is a simple form of fats. So this is my intestinal lumen. This is my intestinal cell on here. Brush water.
You said intestinal cell?
Yes. Intestinal cell. And you see on here, this will be my lymphatic vessel, not blood vessel. So those simple fats that will be resulting from the digestion are going to be my glycerol and fatty acid. And those are gonna be transported from the intestinal lumen to the intestinal cell. But what kind of transport do you think? Active transport, passive transport, diffusion, facilitated diffusion. What do you think?
Well,
Here's those are the glycerol fatty acids. They are already fat. They are fat molecules. They are fat soluble. So would they be able to pass freely through the phospholipid bilayer? Yes. So what kind of transport do I have here? A simple diffusion. Do I require any barrier to transport those fats for me? No, they will be freely diffusing down their concentration gradient from high concentration to low concentration inside the cell. So they will travel by simple diffusion. Did you pay anything here for you to get the glycerol and fatty acids to the inside of the intestinal cells?
Negative.
No. Do I have any limitation for this absorption?
Negative.
No. So whatever the amount of fat I will be eating, it's going to be absorbed into my intestinal cell. I don't have much limitation. All right, so you see on here, you've got glycerol, you've got fatty acids, but I cannot transport either one of them to my circulation, either lymphatic circulation or blood circulation. So try to imagine you have butter moving through your vessels. Right, so what will happen?
They go to your large intestine.
You're going to be blocking the vessels, right? So I need to make those fats. Yes, they did travel for free from the intestinal lumen to the intestinal cell, but I've got a problem here. They are not water soluble. So if I try to get them to travel through my circulation, they will block my vessels because they are not water soluble. So I need to make them more water soluble. The first step is to transform them into neutral fats. And the neutral fat here is going to be my triglyceride. What is a triglyceride? It's one glycerol attached to it, 3 fatty acids. So the first step, in order for you to move those fats to your circulation, is to form triglyceride, neutral fat. But neutrality, it's not enough to allow those fats to circulate in my lymphatic vessels or blood vessels. Neutrality, it's not enough. I need to have some charges. So what you're going to be doing, you're going to be adding proteins to those triglycerides. Those proteins are going to be charged. You add triglycerides to proteins, and proteins to triglycerides. I did form a huge complex of triglycerides and proteins. Would you be able to transport this large complex that you did form through the membrane by passive transport, by simple diffusion? What do you think?
No.
So you did form a huge chemical compound full of triglycerides and proteins. You see on here, all this together is called my chylomicron. This is too big to travel from my intestinal cell to the circulation by facilitated diffusion. There is no carrier that will be able to conduct this large compound. there is no way I can pass by simple diffusion. Why? Because simply you have proteins in your structure which are making you water soluble. So you're not fat soluble anymore to pass by simple diffusion. So the only way for me to move those chylomicrons from the intestinal cells to my lymphatic vessels is by exocytosis. You're going to be collecting those chylomicrons in vesicles, and those vesicles will be traveling here to fuse with your cell membrane, releasing their contents to the outside. So now you've got the chylomicrons released by exocytosis. This is the type of transport that will allow me to conduct the fats from my intestinal cells, not to my blood vessels, to my lymphatic vessels. And then, from the lymphatic vessels, those fats can be conducted to your circulation to larger blood vessels, and will be distributed either to be stored in your adipose connective tissue, or in case of starvation, you're going to be breaking them down by different organs. All right? Questions? So again, how do I absorb the different nutrients? So far, we mentioned proteins. The absorbable forms of the protein are going to be amino acids or dipeptides. Amino acids will pass by co-transport with sodium. Dipeptides will travel to the intestinal cells by co-transport with hydrogen. That will be used to break them the amino acids apart. Now you've got single amino acids in your intestinal cells. Those amino acids are going to be traveling by what kind of transport?
Facilitated.
Facilitated diffusion. Looking on here for the carbs, what are the absorbable form? What is the absorbable form of the carbs? It's going to be monosaccharides. Like what monosaccharides that we know here? Galactose, glucose, and fructose. Glucose and galactose are going to be transported to the intestinal cells by co-transport with sodium, compared to the fructose is going to be transported by facilitated diffusion. All of the three are going to be conducted to your blood circulation by facilitated diffusion. The absorbable form of the fats are going to be glycerol and fatty acids. Would you be able to conduct the glycerol and fatty acids to your blood directly?
No.
Yeah. They will be able to pass by simple diffusion. They are fat soluble to the intestinal cell, but they got stuck inside the intestinal cell. How will I be conducting them to my circulation? They need to be water soluble. And if they are water soluble, they will be huge to be conducted by a carrier. So the only way for me to move those chylomicrons that I will be forming by triglycerides and proteins is to conduct them by exocytosis. You allow the vesicle to fuse, releasing those chylomicrons to the outside in this lymphatic circulation, then will be metabolized in the liver and will be conducted later on to your blood systemic blood circulation. Last type of nutrients that we are discussing is going to be the nucleic acid. You eat DNA. Yes? No?
Yes.
Yes. You tried DNA before? No? No? Anybody did try DNA before? We should go one day. There is a good restaurant.
Every time I eat meat.
Yes, we eat DNA. Why? Because simply any cell has DNA. So if you're eating meat, for example, you did ingest millions and millions of copies of the cow's DNA,
Oh.
of the chicken DNA, because you're eating the cells of the chicken. If you're eating beans, you did eat
DNA is in every part of the living animal.
the genetic material of those beans. So yes, you're eating DNA and RNA in every cell that you're eating.
Yes.
Alright? So what we're gonna do with those DNA and RNA, we're gonna be breaking them down to the simplest form. And remember, the building blocks of the DNA and RNA, those are my nucleotides. And the nucleotides, those were formed by 5 carbon sugars. Those are my pentose sugar. Attached to those pentose sugar, we then have bases like adenine, guanine, thymine, and cytosine in the DNA, uracil in the RNA. And attached to this 5 carbon sugar, we then have a phosphate group. So we're looking here at 3 main structures that will build up my DNA and RNA. We have pentose sugar is a ribose or deoxyribose sugar. Attached to it, you're going to have a base, adenine, guanine, thymine, whatever, and a phosphate. We're going to be breaking down this DNA and RNA into the simplest form by having nuclease, either deoxyribonuclease or ribonuclease. Easy? Ribonuclease will be breaking down RNAs, and DNA is going to be broken down by deoxyribonuclease. Alright, those are enzymes released from the pancreas. You're going to complete the digestion of the DNA and RNA again by the brush border enzyme. Don't worry about the enzymes here coming from the small intestinal cells. The brush border enzyme will breaking down the DNA and RNA. This is a little expensive. You're going to be paying to absorb those structures, pentose sugar, phosphate, and nucleotides from the lumen, from the intestinal lumen to the intestinal cell, and you're going to pay another time to conduct them from the intestinal cell to your circulation. Alright, we don't need to get involved into the details here of the metabolism of each one of those. Alright, so which one is the cheapest to absorb from all what we've mentioned so far? Which one didn't?
Fat.
But exocytosis, is this a passive transport or is that an active transport? It's active. Exocytosis, when you form a vesicle, you push this vesicle, this needs lots of energy. So which one didn't consume energy? We absorb of all those carbohydrate, you co-transport. Co-transport with sodium here. So you pay for co-transport. Which one? Protein, you did pay for co-transport.
I'm guessing it's the last. Yeah, it's got to be the last one.
Okay.
I said carbohydrates. You said which one is cheaper?
Yeah, which one I didn't pay for to be traced, to be absorbed?
Carbohydrates.
Fat I did pay for exocytosis to be conducted from the cell to the blood.
Carbohydrates.
Why you say carbohydrates?
Because it's still facilitate diffusion. Protein and carbohydrate.
That one's got 2 diffusions. That one has 2 diffusions. That's only got 1.
They both do the same.
You didn't pay for it.
That one has 4 times as much.
Carbohydrate. I'm sticking with carbohydrate. I'm sticking with carbohydrate.
So, there is
I'm going with
one
protein.
that you didn't consume ATP to absorb.
Carbohydrate.
Protein.
Carbohydrate.
I'm going to pay here on both.
Carbohydrate.
Fructose,
What?
not carbohydrates, fructose.
Oh,
Just fructose passes by facilitated diffusion on here from the intestinal lumen to the intestinal cell, and then will pass again by facilitated diffusion from the intestinal cell to the blood.
It's under the
So it didn't consume energy to be absorbed. This is the
fructose.
not the whole carbohydrate.
Okay.
Glucose galactose will be consuming energy, here to be transported into the intestine. So we can have a break for time. We come back and discuss more about the digestive system.
Well, I'll ask when we're done. I'll ask after we're done.
What's that?
I'll ask after we're done. Well, no, that's why I was gonna ask, but I didn't know a little bit of high fructose corn syrup. You gotta worry about that. Because it's so easily
Easily
absorbed.
absorbed, yeah.
It causes,
And it's not something safe. Like when you tell a diabetic to consume fructose milk, and if they didn't eat a lot of honey, then it's have a very high fructose. Actually, this will be transformed into glucose.
well, a lot of our diet, everything we not eat, I don't consume it.
Yeah, because this is what will give the taste and good taste, and what makes you have more craving towards it.
Yeah, because it's syrupy drinks and soda, out of juices,
Yeah.
out of I think a lot of things to eat or consume.
Yeah, high fructose. Yeah, because they are trying to make you get used to them. Yeah.
So most of our diet is either high fructose or high sodium. So the stuff you're saying is a lot of sodium with simple sugar.
The sodium is not going to be transported
Oh, yeah.
unless you have sodium all over the place. Yeah, sodium, the presence of sodium is not going to be a major problem, and it will not be affecting the absorption of those nutrients. It's not going to be, so it has to be like fully depleted, which can never happen. Like if you're eating anything has cells, and those cells are those fruits or whatever you're eating has to have some sodium. That allows the absorption, but will not be a major factor that will be affecting the transportation of the nutrients. Might be the presence of carriers. Yes, this might be a factor that will be affecting the transportation of the but not as a sodium. So I didn't hear anything concerning like having a problem on the absorption due to the deficiency in the sodium in the noodles.
Well, I'm going to go over a lot of this stuff again, not in this chapter, but I guess it's a chapter on nutrition, metabolic. It's going to cover some stuff.
We're gonna go to the metabolism. We're gonna cover the production of energy from the glucose. This is one thing. The other things that we're gonna be discussing also is the fat metabolism. We're gonna see how to break down fat, how to use it to generate the energy, and the breakdown. Like a general overview, we will not get details like in biochemistry. So we're gonna start and rely mainly on glucose, then we're gonna relate fats and proteins to the glucose. But we will do this next class. Hopefully I get time today to complete the reproduction.
Yeah, I'm trying to minimize some of it. It'll take too much time.
It's okay.
You said 10 minutes? Thank you.
Yeah, so you can, for example, yeah, so like you like the numbers are back in order. Yeah, so the digestion. And you figure it out just from the appearance, but you don't remember the exact name. Try to write it down.
I can't remember what it is, it just, I can't at all. It was just, I'm gonna write it down.
Alright, good luck, good luck.
I'm staying for another year before I go to college.
Okay. Yeah, we do kind of go there. That's down in Tampa, no? Because the one, oh, yeah, because that's, the one in Tampa is, that's gold. It's a big but there is another one in
Probably Digestive.
no, not Gold. It's for medical. There is one in Jordan for medical.
Hold on, cause I got a bad grade. What? What? What's today? What the heck? 415 out of 417.
For here or
What the heck? I'm getting so mad.
for the second step out of the classroom.
Exactly. So like, why is there
Because whatever packet he gives us, the whole test will be on that one packet.
This lady is definitely freaking. Hey, I'm seeing, when you gonna put the extra food? Cause I need to see that.
I didn't even fall asleep. They should have been left for 5 minutes.
I saw you, I'm like, dang, he into it for real.
See, I don't sleep at night.
You work at night?
No, I just don't sleep.
Same way.
Do you sleep during the day?
No. But I'll like tell.
Why don't you take night class and then you sleep during the day?
I take medicine. 20 years of menstrual cycle.
Oh, wow. So your cycle was messed up. You had some. Yeah, I know the military and all, but how did the military make your cycle? Because I'm considering going into the military.
They don't let you sleep.
If you consider going to the military, first off, finish college. Second off, go to Air Force.
Of course.
That's enough. It is. They call it sleep deprivation. Sometimes you gotta be out at night. Doing operations at night. So,
Oh, because of your job. Oh, okay, because of your job specifically, not because of the branch, but the job that you picked.
well, I mean, sometimes, because then they got these things that you have to do. Watch or guard.
Yeah, I heard about watch.
Sometimes the simple act of being paranoid for a long period of time will mess you up enough to keep you awake all the time.
Paranoid?
Yeah.
Paranoid? You have a reason to be paranoid?
Having your head on a swivel, I mean, especially if you're overseas on war, yeah, you gotta be paranoid all the time. Otherwise,
I will.
You won't really have to worry about
you ain't gonna worry about war. You ain't gonna worry about shit. Let me tell you something, because I'm in the army now. Granted, I went in the army, but even though I was in the army, I went into the aviation part of the army. I worked on Apache helicopters. Okay. I was thinking, okay, anything happens, I'm cool. I'm in the back of the line anyway. Shit popped off in 01. That all changed. The whole battle plan changed. Everything changed. There was no more back of the line for aviation. It was everybody moves at once. Blows my plan out of fucking water. You know what I'm saying? So yeah, that. And I'm aviation. I got caught twice. That was because they had me on a downed aircraft recovery team in Dartmouth.
So that means like your school.
Huh?
Your schooling is paid for, right? Don't they give you a bunch of money if you get hurt?
If I wanted to get my GI Bill, yeah. I mean, they would pay for a little bit of it.
Yeah, you should get it. Like, don't even get hurt in the military. Like, they pay for it.
It ain't enough for me. It ain't enough to even scratch, like make a dent, like for a semester. The best I get is credit.
Okay.
So I say go to school first, get your degree, then go to the military, then you get that degree. You get a degree, oh.
Yeah. You know what Air National Guard is like?
Air National Guard is you're gonna be like
Yeah,
looking.
I was thinking about doing that.
It's pretty much.
While I'm in school, they said they pay 100% your school tuition.
Your parents.
My homeboy's dad's in the Air National Guard. He basically just worked out at the airport and worked on the F-15s at the airport.
There are different levels of reserve. The reserve is like 1 weekend a month. Or you go like 2 weeks out of the year. Okay. Or you go active reserve. Active reserve is like having a job. So you go every day.
Okay.
It's like a job.
Or that's actually called active National Guard.
Oh, I was going to say, like,
No, but what I'm saying is, if you want to go to the second one, because it's like a job, that's when you get like free school.
oh.
But when you reserve, you're only active when you're doing something. So if you're trying to do it while you like not doing it, you're not getting that free.
Oh, wow. Yeah, but I mean, I got
you can have your regular job and do military.
And then I was thinking about switching to Air Force after I get there. So after I switching from Air Force, what did I just say?
But if you go to active reserve, you go to like a regular job.
But what's better though, Air Force or Air Force?
Air National Guard.
Air National Guard, yeah.
Air Force.
Air National
Air
Guard is
Force.
basically you're working for the state.
Yeah, you're kind of contracted out by the state through the Air Force.
So I should do Air Force?
Yeah, just stay Air Force.
You still gotta go to Air Force weekend, Air Force school, but you gotta come back here.
Air Force. They ain't getting paid.
What?
People do not join the military for the money. It ain't happening. It might be more money than you've ever made.
That's why I say go. That's why I say finish.
I mean,
Y'all saying like the Air Force is paying?
the military in general does not pay well. I mean,
It's like this.
when I was in,
It's like this. When you're an officer, you get paid basically. When you're not an officer, you get paid below minimum wage.
yeah,
The reason why they make so much money because it's accumulated. You work, you get paid.
My
So
ascending
you're on the clock 24 hours.
yeah, you're not-
ascending cooler will be conducting the pieces now to the part of the cooler that travels
Transition.
horizontally. This is going to be my transverse cooler, then will travel downward. It's my descending. Then I have this S-shaped part of the cooler. This is my sigmoid cooler. Then the pieces now will pass through the straight part of the cooler. This is the rectum. Remember, recta is straight. The rectum will then conduct the pieces to the anal canal. And the anal canal is going to be guarded by two sphincters. I have external anal sphincter and internal anal sphincter.
If you go back to the picture, what's that gray part?
Green part.
The gray part. What is the gray part? No. Just a little gray part that's running. Yeah. Yeah, what is that? Yeah.
This is
talking about the tinea
tinea
cord? Oh, yeah.
Don't worry about it.
Oh, I'm just curious.
So you get some.
She hasn't did the 128 questions yet.
Okay.
She ain't did that.
We can discuss that. We just focus on the main parts. We have the cecum, and attached to the cecum, this pouch-like structure is gonna be the vermiform appendix. Vermiform, vermis is a worm-like. So it looks like a worm. Cecum, ascending, transverse, descending, sigmoid, rectum, and the anal canal. Gonna be guarded by two sphincters, external anal sphincter and internal anal sphincter. But it's not shown on the diagram, internal anal sphincter. So what I want you to see on here also is those flexures. I have right colic flexure and left colic flexure. So this, another name for this, for the right colic flexure is gonna be the hepatic flexure, because on the right side, you're gonna have the liver, and the left colic flexure is gonna be called the splenic flexure, because on the left side, you're gonna have the spleen. All right, so right colic flexure, left colic flexures, those are gonna be connecting the ascending to the transverse colon, and the left colic is connecting the transverse to the descending. All right. So what are the digestive processes that will be taking place in the small intestine? Can you remind me? Do I have any chemical digestion? The small intestine, do I have any chemical digestion? Small? Yes or no? Yes. Most of it will be taking place in the small intestine. Do I have any absorption?
Yes.
In the small intestine? 90% of the absorption is going to be taking place in the small intestine. And do I have any propulsion?
Yes.
Yes. So everything here, the answer is going to be A, B, and C. All right. So moving on to the next part of the large intestines is going to be the rectum. The rectum will have 3 rectal valves. Why do we have valves in the rectum? For you to not pass feces with the gas. So what holds the feces when you're moving the gas out is this going to be the rectal valves. They will allow the gas to travel to the outside, holding the feces inside. That's why you don't have much control on the passage of the feces to the outside if a person has diarrhea, because those rectal valves will hold only solid parts, not liquids. All right, so when you're trying to pass gas and you have diarrhea, you will lose the control.
That's why Jack Nicholson said, never trust a fart.
All right, here the rectal valves will not be able to hold this liquid. All right, so normally why every time you're passing gas will not be accompanied with feces, simply because the rectal valves are holding the feces from moving to the outside. Anal canal is the last segment of the large intestine, and it's going to be guarded again by internal is involuntary, like what we've seen with the internal urethral sphincter. Internal is always involuntary, it's going to be formed of smooth muscles, and the external is going to be voluntary and it's going to be formed by skeletal muscles. So you're going to have same concept on here in the anal canal. This is going to be internal anal sphincter formed of smooth muscles. External anal sphincter is going to be formed by skeletal muscles. What are the major functions here of the large intestine? I'm allowing absorption to take place, and mainly what's going to be absorbed in your large intestine, mainly water and vitamins. And again, why do I wait to get the vitamins on here? Because they got formed in the large intestine by the bacteria. Like what vitamins do you absorb in the large intestine? Like vitamin B and vitamin K. All right. Also, it allows propulsion. And finally, is defecation. Defecation is a major activity here of the large intestine. Colon is not essential for life. So a person can, if a person has a colon cancer, for example, we're going to be removing large segments of the colon, and I might have colostomy, getting the feces out from a hole there through the skin to the outside to be collected in a bag. All right, I can survive without the colon. All right, colon is not essential for life. You're going to be taking supplements to substitute those vitamins that you're not absorbing. You're going to be taking more fluid to replace this fluid that you're losing, that you're not absorbing, but it's not essential to survive. All right, so moving on to defecation. Defecation, is this a voluntary or an involuntary process? Both. I have the stretch of the rectum will be stimulating the rectum to contract, and in the same time it will allow the internal anal sphincter to dilate. This is the involuntary part. But the voluntary part is the relaxation of the external anal sphincter. So we have two parts, exactly like what we've seen with the micturition. When we fill the urinary bladder with urine, the urinary bladder will contract, and the internal urethral sphincter did dilate. This is involuntary. This is under the effect of parasympathetic nervous system. Same for defecation. When you stretch the rectum will contract, and internal anal sphincter will dilate. The voluntary part is due to relax the external sphincter. External sphincter is going to be controlled by conscious control. I have it's going to be under voluntary control. Moving on to the homeostatic imbalances that will be related to the digestive system. First homeostatic imbalance that will be related here to the digestive system is GERD, gastroesophageal reflux disease. What is the problem with GERD? GERD, I am passing gastric acid up into the lower esophagus. Risk factors for having GERD: smoking, for example. Why? Because it relaxes the sphincter between the esophagus and the stomach. So when you relax the sphincter, you're not contracting the sphincter that holds the gastric juices inside the stomach. The gastric juice will travel up into the lower esophagus. And this puts me at the risk of developing an esophageal cancer. Why?
Because of the
I
constant
have constant irritation.
erosion. Yeah.
Constant irritation. So, and why I cannot tolerate those acids in my esophagus? Can you remind me what kind of epithelial lining you have in the esophagus? Stratified squamous epithelium. Compared to the rest of the gastrointestinal tract, starting from the stomach, is going to be covered by simple columnar epithelium. So stratified squamous epithelium, do you produce any mucus covering to your epithelium? No. So you're going to get in direct contact with those acids, and this will cause the irritation of your epithelium, putting the person at risk of developing inflammation first, esophagitis, ulcers, and if not treated, it's going to progress to cancer. That's why if you went to your gastroenterologist and you told him, I have burning sensation in the gastric region, he will tell you, we're going to need to perform an endoscopy. Passing by a camera to the inside, upper endoscopy, to check if you do have ulcers, if you do have inflammation, and we need to take cells to check them out if they are pre-cancer, if there will be precancerous lesions or not, and for him also to make money.
You can secondhand smoke if you're like if you're like constantly in him.
If I might have like a hernia, like hiatal hernia, for example, this sphincter will not be effective to hold the acids down in the stomach. If I have a hernia, part of the stomach is herniating up in the chest, for example, hiatal hernia. So many things might contribute in getting GERD, like having a heavy meal before going to bed, for example. This will cause reflux. No, it's gonna be on and off in order to be considered GERD. So once you've got it, this is GERD. This is very common, like almost 80% of the people that have GERD are due to various reasons. All right, so inflammation of the stomach, this would be gastro is stomach, itis is inflammation. Gastritis is an inflammation due to any reason that will cause deterioration of the mucosal barrier. Like what might cause deterioration of the mucosal barrier on here? Like they Helicobacter pylori. Helicobacter pylori, this is a difficult bacteria that it's not breaking down the wall of my stomach, causing the peptic ulcer. It's gonna be just inhibiting my cells from producing mucus covering. And if you didn't form a mucus covering of your stomach, what's gonna happen? You're gonna be digesting your own stomach. And that's why if you're taking aspirin, we tell you don't take aspirin on an empty stomach. Why? Because aspirin is going to be preventing the formation of the mucus of your gastric mucosa. So you are interfering with the mucosal covering, and this puts you at the risk of developing an ulcer. First, it starts with inflammation, gastritis, and if not taken care of, it will progress to a peptic ulcer or gastric ulcer. All right? Hepatitis. Hepatitis is an inflammation of the liver due to an infection, and we have different hepatitis viruses that go from 6 different types: A, B, C, D, E, and F. Those are the different hepatitis viruses. Some of them will cause acute inflammation. You either die or get rid of the infection. And some of them will cause chronic inflammation. You will not discover that you've got this disease until you destroy most of the liver. So it has been ongoing, an ongoing infection for years, but you will not figure it out until late in the disease. So like hepatitis B and C. Hepatitis B and C will most probably cause chronic inflammation, chronic hepatitis, compared to hepatitis A. Hepatitis A causes acute hepatitis. So you either get jaundice, an acute attack of jaundice, you get rid of the infection, or some people will develop something called fulminant hepatitis. I will have an aggressive reaction in the liver, causing a full destruction of the liver in a very short period of time. So I will not be able to survive the infection. All right, compared to the B and C, they will cause chronic infection. Cirrhosis is a destruction of the normal architect of the liver. This might be due to viral hepatitis or might be due to alcoholism for years. So alcohol consumption is a risk factor for developing cirrhosis, and this is actually the most common reason for cirrhosis in the US. What is the problem? If I lose the normal architect of the liver will lose its function. Yes, although you're going to be building up new cells to replace the dead cells, but because of the chronic inflammation, those cells will not be arranged in a way which will allow normal function of the cells. So what's going to happen? I will develop ascites, for example, because I'm not able to build up the proteins in my liver. I'm accumulating fluid in my peritoneal cavity, in my abdominal cavity. I will, for example, develop jaundice because this bilirubin is resulting from the breakdown of the red blood cells, and this bilirubin is going to be uptaken by the liver cells to be released out in the bile. And if I have a liver destruction, I'm not able to pick up this bilirubin from the bloodstream, so it will accumulate in the bloodstream, causing yellowish discoloration of my skin and sclera. This is what we call jaundice. I will develop esophageal varices, so bulging vessels in my lower esophagus, which might rupture, and I will be vomiting blood. Why? Because when you lose the normal architect, what drains into the liver are all your abdominal organs, remember? through the hepatic portal vein. So if I did destroy the liver, it's not able to get any more blood from the other abdominal organs. So the blood will start to accumulate within the veins of those organs. This includes my lower esophagus. And as we've learned, the veins will have thin walls. They cannot tolerate the high pressure. So they will start to form sacs filled with blood. Those sacs might rupture, and this would be one of the latest signs of cirrhosis. All right, so might be due to chronic consumption of alcohol. Also, it might be due to viral hepatitis, especially C and B. Moving on to our last homeostatic imbalance that will be related to the digestive system. This is going to be the colon and the stomach cancers. The problem with the colon and stomach cancers is that they rarely have early signs or symptoms. They rarely have early signs and symptoms. Why? Because you're not confronting anything around. You have a large space inside your abdomen that you can grow in. So if I have a colon cancer, most of the patients with colon cancer will not be manifesting with any signs related to the colon itself, but they will be manifesting signs of the metastasis. So the colon cancer will start to migrate and will send cancerous cells to the liver, and the patient will develop signs of liver problems rather than the colon cancer, the original cancer itself. And it's going to be so late in the disease, so it will need aggressive management. So you're going to be taking out the lobe of the liver, you're going to be taking parts of the lungs, you're going to be removing parts of the large intestine. So it needs a very extensive management if it was manageable. So in some cases, you will not be able to manage your patient. So if it's, for example, invading the spine,
That's all she really
you cannot do anything. All right. So early detection is the best thing. That's why we do recommend people, especially with those who have relatives that did die from a colon cancer, to have a lower endoscopy to check if there is any precancerous lesions like polyps. All right, those are all those. We don't have early detection of stomach cancer on a regular basis, like what we do for the colon. But in other countries like Japan, for example, they do have regular checkup for stomach cancer because it's much more common in Japan compared to here. So it's not part of the regular protocol to check for stomach, but it's part of the regular protocol to check for colon cancer. All right. Let me go over the main
Wait, so
diagram.
because it's not part of the protocol, they just don't do it? That don't make no sense.
Well, we don't get that much over here, so we're not gonna test for it.
None of the diagrams of the metabolism gonna be on your lab, only the diagrams of the reproductive system and the digestive system. Only diagrams from the digestive and reproductive system. Let me go over the diagram of the reproductive system. What must be on your test diagram is the section showing the external and internal reproductive organs of the male reproductive system. Must be on the test 10 stars out of 5. So there is no way I can test you on reproduction without this diagram. Everything, every single marking on here needs to be.
Even the diaphragm?
Even the diaphragm. You need to know the spell. You need to know the spell. Right? Another must be on your test is going to be section of testis. Spermatic cord, veins, vas difference, everything. Rete testes, seminiferous tubules, lobules, tunica albuginea, tunica vaginalis, everything on the diagram is going to be on the test. Very, very important. Another highly important diagram is a male reproductive system. It's going to be diagram showing the same structures like the previous diagrams, but from a different perspective, from a different view. Those are the same exact structures that we've seen, with few exceptions. Here are the details of the penis. The new structures are the three parts of the penis: root, shaft, and glans, corpora cavernosa, corpus spongiosum. Those are the new structures that you have on this diagram compared to the other two diagrams. This is highly, highly, highly important. I will rate it 5 stars out of 5. Diagram on the spermatogenesis. This is not going to be on the lab. This is going to be part of the regular physiology questions on the lecture. Same for the hormonal control of the spermatogenesis, FSH and H. All this is going to be part of the lecture exam, not the lab exam. All right. Another must be on your test. 10 stars out of 5. Every single marking on the diagram is going to be testable. The section showing the internal and external reproductive organs of the female reproductive system must be on your test. Must be on your test. Another must be on your test is going to be the internal reproductive, female reproductive organs, an anterior view. So this one is also 10 stars, 10 stars out of 5. This ovary is 5 stars out of 5. It's highly important, but it doesn't have much details. Doesn't have much details on it. We have the Grecian follicle, the mature follicle. We have the antrum. The structure of the Grecian follicle is testable. Structure of the Grecian follicle is testable. So we're going to call this space filled by fluid. This is the antrum. We're going to call the cells that are directly in contact with the egg inside the Grecian follicle. This is going to be the zona pellucida. Zona pellucida. The cells that will form a crown around the ovulated egg. This is what we call the corona radiata. Corona radiata. What do we call the yellow body on here? Corpus luteum. Corpus luteum. All right. What kind of egg do I have in here? Primary, secondary, ovum, ovonium, which one? Primary oocyte. What about this one? Secondary oocyte. You complete meiosis 1. Under the effect of NH surge, which gonna be responsible for the maturation of the primary into secondary oocyte as well as ovulation. So the ovulated egg in here is gonna be secondary. The one inside any of the follicles is gonna be primary oocyte. All right. This clears this very common wrong answer. Those are very common wrong answers on the test. Those are very common wrong answers on the test. Which one is this follicle, for example, secondary follicle? What kind of egg do I have inside? Primary oocyte. What is this follicle on here? Primordial. What kind of egg? Primary oocyte. This one? Brachial follicle. What kind of egg? Still primary oocyte. All right. Oogenesis, folliculogenesis. The ovarian and the menstrual cycles. This is a long essay question on your lab part. You need to explain oogenesis, folliculogenesis, the ovarian cycle, changes taking place in the ovary throughout the month, and how those changes in the ovaries are going to be corresponding to the endometrial changes, explaining the 3 phases of the menstrual cycle, hormonal regulation as well. All right, this is a huge essay question that you need to spend enough time to prepare for it. All right. I will post also for you. I will post a recording, a video recording on Blackboard for you to remember what we did discuss in class about this class. And this is going to be covering everything that you're going to need to mention, but you need just to write it down in a logical pattern and keep repeating it for you to be able to write this down on the test. This is a big exam. This is a 200 points exam. This is a huge exam. 200 points exam. This is going to be a part of the question as well. So nothing is important here as a diagram, but all of them together are going to be under one big essay question. All right, oogenesis, folliculogenesis, ovarian cycle, and the menstrual cycle, as well as all the hormonal regulations that are taking place. All right? This is a big essay question. All right, so next time we're going to be discussing those menopause and another diagram before I forget, in the reproduction is going to be the mammary glands of the breast. Right, we're going to discuss this next class. Right, it's going to be highly important. 5 stars diagram. 5 stars diagram. Lab. This is for the reproduction. For the digestion diagrams, digestive system diagrams. A very basic diagram. Very basic diagram, and I will rate it 4 stars out of 5 because it's very basic.
Okay.
A 5 stars diagram is going to be showing the different layers of the gastrointestinal tract mucosa, submucosa, musculosa, and serosa, and your like
So all of it,
everything is going to be important on this diagram, yes. A sagittal section of the oral cavity showing its boundaries. It's highly important. A 5-star diagram. 5-star diagram. And again, everything on the diagram is going to be testable. An anterior view of the oral cavity. Everything on it is going to be testable also. 5 stars diagram. Diagram showing the tongue. I will rate 4 stars out of 5. The only thing that I want you to identify on the diagram is going to be the 4 different types of peptide. Nothing else except for those 4 types of peptide. All right. A 3 stars diagram. 3 stars diagram. The only important thing I want you to identify is the different salivary glands. So you need to remember that this is called the parotid gland. This is the duct of the parotid gland. This is called the sublingual. This is called the submandibular. So this diagram, this 3 stars diagram, what I want you to remember in this diagram is to identify the different salivary glands. And that's it, nothing else.
just the ones that I'm read.
Yes. Those are, I can attest you on the leftist one. You need to be able to identify the 3 glands and the parotid duct. Duct, yeah, parotid duct. A 10 stars diagram would be a diagram showing the different parts of the stomach. Again, different regions: cardiac, fundus, body, pyloric entrance, pyloric canal, pyloric sphincter, duodenum, greater curvature, lesser curvature. If I have multiple arrows on here showing the elevated ridges in the mucosa of the stomach, I mean by this, the rugae of the mucosa. Alright, if I have the dotted part on here, I mean by this is the pyloric canal. Alright, so if you have multiple arrows pointing to different ridges, those are the rugae. The entrance is this one. Another must be on your test. 10 stars diagram is going to be a diagram showing the liver, pancreas, and the duodenum, and the relationship between the different ducts, gallbladder in the main pancreatic duct, along with the hepatopancreatic ampulla with the major duodenum pepper. All stuff on this diagram are highly important. This is the 10 stars diagram, must be on your test. Another must be on your test is going to be the different parts of the large intestine. Only the main structures you need to identify. So only the structures that we've discussed: vermiform appendix, cecum, ileocecal valve, ascending, transverse, descending, sigmoid, rectum, anal canal, external anal sphincter, and the ileocecal valve, along with the right and left colic flexion. Anything else, it's not going to be tested. Only the main parts in the. And how would I know the main parts? Those are the ones mentioned on the previous and the slide that comes after that. Those are the main parts that you need to understand. All right. be highlighting those ones for you to not get confused. I will post them for you. Alright, to make it easier for you, I will be highlighting those structures that you need to know on this diagram, like what it is with the heart and blood vessels. Alright, I will highlight those structures. We'll be posting there for you. Alright? Let me double check if there is any other diagram. Alright, so
Now this,
alright, so our test is scheduled to be on the 26th.
next 2 years.
I am planning to move it 1 week. Okay,
As long as a week ahead and not a week up before.
April 2nd. Opinion. Just thinking. Right? So I need to take your opinion. So would you like to take it on the 26th or you want to move
The
it on
second.
the
Second.
Are you serious?
on the 26th?
No. Put your hand up.
Put your hand down. Put your hand down.
April 2nd.
You might as well put it down.
Again, 1 week for you to have enough time, but I will be conducting a quiz.
Okay.
Alright?
I can
Just
do that.
to check
Yeah, do what you
I
need
can
to
do
do.
how you're studying.
Do what you need to do.
Yeah,
I feel it's necessary.
next class covering reproduction and digestive diagrams.
Wait, what's the good one?
The reproductive and digestive diagram.
Okay, so this stuff.
It's like a pop quiz.
Right. Yeah.
Middle, left, within something.
So he does have a.
It's nothing to do. I will be just handing out exercises for you to do at home. This is the middle lab. We will not be doing something hands-on in class. You're gonna be measuring your body weight, those stuff that you're gonna be conducting at home.
While he was going over all those diagrams.
Yeah, I still gotta study for chemistry next week. Like, girl, we got chemistry next
See,
Monday.
I forgot about that. And
Really?
I have to start studying for that. Because I need to actually get a good grade on one of these tests.
Right.
Because I got like a,
I'm still listening.
when she drops one of them, my best grade would be like the 75 I got, which I could do it if I can get like a high D grade.
I'm gonna say,